This is the introduction to section 3.9, which is on antiderivatives. So we're going to start working backwards after all of our work taking derivatives and applying them. So the first question here is, given f of x equals x to the fourth, can we find a function, call it capital F, it doesn't matter what we name it, such that its derivative is equal to f of x, and how many such functions are there? Okay, so we want to find a function whose derivative is x to the fourth. Well, what do we know? We know that the derivative with respect to x of x to the fifth is 5x to the fourth. So that's close. It almost does the job for us, but it has this constant of 5. Well, if I want to undo that constant of 5, what would I multiply by? I'd multiply by 1/5. And so one such function, capital F, looks like 1/5 x to the fifth. And in this case, f prime then is 1/5 times 5x to the fourth, which is x to the fourth. Okay, so there's one such function, capital F, but how many other such functions are there? Well, let's see, I think if we're tricky, we can write another function down really quickly. We could write down a function f of x that looks like 1/5 x to the fifth plus 11. That doesn't change the game at all when we take the derivative, because the derivative of 11 is 0. We could continue to play this game. We could have called f of x 1/5 x to the fifth minus 300. Still doesn't change the game. In fact, we could put any constant there. Right? And when we take the derivative of that constant, we're just going to get 0. So the most general antiderivative, the most general capital F, is f of x is 1/5 x to the fifth plus a constant, where this is any real number. Okay, so here's a definition. F of x is an antiderivative of little f if f prime is equal to little f, and also is the most general antiderivative is capital F plus a constant. Okay, so we have an antiderivative. That's these functions up here. This function is an antiderivative. This function is an antiderivative. Those are all antiderivatives of x to the fourth. The most general one is this one, which looks like 1/5 x to the fifth plus a constant. Okay, before we move on, what did we do to undo the power rule is really what we're doing here, right? We went from x to the fourth to x to the fifth, and what did we end up doing? We ended up, in essence, dividing by 5, multiplying by 1/5. So we went to one more power, and then we multiplied by the reciprocal of that power. So we went up to the fifth power, multiplied by its reciprocal, which is 1/5. Okay, let's put that into practice here. Find the most general antiderivatives of the following functions. Okay, so these are all going to end with plus a constant. Let's start with f here, and let's call this general antiderivative capital F. Okay, we're going to put the same practice that we did last time. We go up one power, multiply by the reciprocal. So we go to x to the third and multiply by 1/3, which is the reciprocal of 3, minus 3 times, we go to x squared, and we need to multiply by its reciprocal, which is 1/2, plus 2x, multiplied by the reciprocal of 1 is 1, and we add a constant. And so our most general antiderivative might be written this way: x cubed over 3 plus 3/2 x squared plus 2x plus a constant. If we ever wonder if we took the correct antiderivative, what do? We take the derivative and check. If we did that in this case, we would get exactly that function small f of x. Okay, there's another example. This one differs a little bit. It looks like we want to undo the quotient rule here, but instead I think our best bet might be to rewrite the function f of t first. So really, let's take that one step at a time. This looks like 1 plus t plus t squared times t to the negative 1/2. We'll learn how to undo the quotient rule in Math 142. So for now, we're going to rewrite this in a way that will allow us to undo the power rule. So we get f of t. Let's distribute that t to the negative 1/2. We get t to the negative 1/2. Let's see, t to the first, 1 minus 1/2 gives us t to the positive 1/2. And finally, this is t to the 4/2 minus 1/2 is 3/2, so t to the 3/2. So all we've done is rewrite the function. Now we're in a situation where we can use the power rule. Same thing happens here, capital F. What does it look like? Well, t gets raised to 1 more power, so negative 1/2 plus 1 is positive 1/2. We multiply by the reciprocal of 1/2, which is 2. Plus t gets raised to 1 more power. 1/2 plus 1 is the 3/2 power. Multiply by the reciprocal of 3/2, which is 2/3. Finally, we get t to the 3/2 plus 1 is the 5/2 power. Multiply by the reciprocal of 5/2, which is 2/5, plus a constant. And again, if we're uncertain, take the derivative of capital F, and you should get exactly to small f here. Okay, another example here with some trig functions. Okay, so let's think about this. We need to know a function whose derivative is sine. So let's do some work on the side over here. We know that the derivative with respect to theta of cosine is negative sine theta. And we know that the derivative with respect to theta of sine is cosine. Well, that one's good because we have a cosine, but we have a positive sine. So how does that change things? Well, the derivative with respect to theta of negative cosine, negative times negative is positive. It just comes along for the ride, is sine. So our function over here then, capital G, is equal to 2 times the function whose derivative is sine. That function is negative cosine, minus 11 times the function whose derivative is cosine. Well, that's just sine, plus a constant. So this is negative 2 cosine theta minus 11 sine theta plus a constant. Again, remember this negative here in front of the cosine. Let me point at it. This negative here in front of the cosine is not a subtraction sign. There's always multiplication going on there. So it is negative 2 cosine theta plus a constant. Okay, let's put this into practice in one example in context and then another example out of context. So given a particle's velocity, v of t is 12t minus 30, in that the position at time 0 is equal to 2, find the position at time 4. Okay, so what do we know? We know that the derivative of position is velocity. So we want to step backwards like we've just been doing from velocity to get to position. So let's do that. Let's step backwards first. So we know if we're given the velocity function and we're going to step backwards here, the position function, well, we have 12 times t gets raised to 1 more power, and we multiply by the reciprocal of 2, which is 1/2, minus 30t plus a constant. Okay, so the position function then is 6t squared minus 30t plus a constant. And now we want to find s of 4. Well, if we put 4 in there for t right now, we're going to have a constant left in our expression for s of 4. But maybe we can use this last piece of given information. That says when I put 0 in for t, I get 2 out. So it says 2 is equal to 6 times 0 squared minus 30 times 0 plus c. And we can quickly see that c is equal to 2. Okay, great. So now we can finish the job that we wanted to. So this tells us that s of t then is 6t squared minus 30t plus 2. we've been asked to find s of 4. So s of 4 is 6 times 4 squared, which is 16, minus 30 times 4, which is 120, plus 2. What's that? 96 minus 120, that's negative 24, plus 2 is negative 22. So this particle has moved backwards by the time it gets to 4 seconds in its journey. Okay, let's do this again, but now let's step backwards twice and see what happens. Given that f double prime is 3x squared minus 2x plus 4, f of 0 equals 2 and f of 1 equals 4, we want to find f prime. Okay, so we haven't been given any information about the first derivative, except that if we step back from the second derivative one step, we should get to the first derivative, and then we step back from there, we'll get to the function f. So let's do that, and let's make both of those steps because our only given information is about the function f, not about f prime. Okay, so let's first step back to f prime. It's going to be 3 times, x is now going to be raised to the third power, and we need to multiply by the reciprocal of 3, minus 2 times, x is going to now be raised to the second power, we need to multiply by the reciprocal of 2, plus 4x, plus some constant. So let's see, f prime then is x cubed minus x squared plus 4x plus a constant. Okay, now we have enough information. C is just some number. I don't know what it is yet. I'll find it eventually, I hope, since I've been asked to. But we have enough information then now to step back to f. X goes to the fourth power, we multiply by its reciprocal. So we get 1/4 x to the fourth minus, to the third power, we multiply by its reciprocal, 1/3 x cubed, plus squared, multiply by 1/2. 1/2 of 4 is 2, so 2x squared. If this number was 11, if it was 38, you'd tell me that the next step up is 38 times x or 11 times x. So in this case, it is just c times x, but we need another constant. And it's probably not a good practice to name it c because we don't know that it's the same constant, so we'll give it another name, d. Okay, so our job, let's see, what do we want to do? Let's make sure we know what we've been asked to do. We've been asked to find f of x. Okay, let's do that. What do we know? We know if we put 0 in for x, we get 2. So let's write down what we learned from these pieces of given information. F of 0 is equal to 2. Says I'm going to get 2 out if I put 0 in for x. 1/4 times 0 to the fourth minus 1/3 times 0 cubed plus 2 times 0 squared plus c times 0 plus d. When everything, sorry about that, when everything clears, we have d equals 2. All those zeros. And now let's use the other, let me change colors, let's use the other piece of information. The other piece of information says that f of 1 is equal to 4. Okay, so that means if I put 1 in for x, I get 4 out. All right, I'm not going to write this one out in as much detail, so I get 1/4 times 1 to the fourth is 1/4. Golly jeepers, sorry. I get 1/4 minus 1/3 plus 2 plus c times 1 is c plus d, which I know already I've solved for as 2, right? D equals 2 comes down here. All right, now I just have some arithmetic to do. Let's see, we get 4. Let's see, 1/4 minus 1/3. So it looks like these 4's are going to cancel, the 2, 4, and the 4 on this side. And so we should get 0 equals 1/4 minus 1/3 plus c. And so then c is going to equal the 1/3 becomes positive and the 1/4 becomes negative when we solve. So that's 4/12 minus 3/12, or 1/12. Okay, so we got c and d, and we can bring them back up here and get to our function f. So let's do that. So f of x what was it? It's 1/4 x to the 4th minus 1/3 x cubed plus 2x squared plus cx, which is 1/12x, plus d, which was 2. Okay, there we go. That's an introduction to antiderivatives. See if you can use that information to work through the section 3.9 activity.